All right, another very short one. This is key space. Okay? Does everyone agree that with one key and one lock, I could open this fairly quickly? Pretty easy. Now, what if I have two keys and one lock? Could I open it fairly quickly?
Yeah.
I have a 50% chance of getting it on the first try, then I can try the second try. So if my key space was 2, I've already increased the time it takes to open it by 50%. Okay. Now what if my key space is 3? Could still do it. You ever see Amazing Race where they put like the 50 keys on the ring and they got to figure out which key unlocked? You know, it could take a while, but still 3 is manageable. Okay. So would you feel secure if there was 4 different keys? So if I was buying a lock for my house and I went to Lowe's, I can't go to Home Depot because they have credit card problems now. So I went to Lowe's and they sold locks, and every 4th lock had the same key. Would you feel secure in buying that lock system? Heck no. That means half the neighborhood, or a quarter of the people buying it has the same key as you. So that wouldn't be a good option. Okay, but how about 5 keys? Can I live with that? I'd definitely buy that one. Yeah. So the point is, the more keys you add, I'm going to have to sit there and at least try 5 things. How about 10 keys? How about 50 keys? So is 50 keys enough? I mean, is it a point where you would feel safe with 50 different combinations of keys? Okay? All right, let's cover binary real quick. Okay? We're going to get back to the keys. If you don't know how to count the binary, it's actually very simple. It's much easier than decimal. Decimal is 0 through 9 and 10, that kind of stuff. Binary is 0 through 1. Then you go back. Okay? Basically, in decimal, we get to 9, which is our highest number. We increment it and change it to 0. So 9 becomes the 0, and we increment the next value. You get to 99, we increment to 1, and they both change to 0. Okay? Binary is the same way. It's just that we only work with 2 numbers. It's just that we're not used to doing it. Okay? I taught my stepson binary, and he learned it instantly. He has a slight form of autism, so he can pick up on numbers real easily. And he went to Carl Albert Middle School, and he was in there telling the teacher all about binary, and the teacher was like, well, whatever. I have no idea what you're talking about. And it was funny because we had a teacher's conference after that. He says, yeah, David came in, he was trying to explain all this stuff about binary, and David was trying to explain to all his classmates. David can hear it one time and get it. But not everybody is that quick. And he was getting very frustrated that his classmates weren't picking up binary. So he was getting very upset. But he literally, and I showed him what ASCII was, which we're going to do in this next project. And he'll literally just write a binary message on the board now. He just converts it in his head and is like, wow. Okay, all right. So that's what binary is, okay? So 2 to the 1 is 2 possibilities, 1 or 0. Okay? Easy enough. 2 to the 3, or 2 to the 2 is 4 possibilities. So it's 2 times 2. 2 to the 3rd is 2 times 2 times 2. Okay? So far, so good? Everybody with me? So we're just seeing the number of possible combinations of numbers. Okay. 2 to the 4th will be 16 possibilities. Nothing new here. It's actually hexadecimal now. Okay? Okay, so what if I had 2 to the 8th, which is 256? Would that be enough? So if I had 256 keys, would you feel safe? How about if I had that big number at the bottom? What is that? That's 33,554,432 possibilities. So if you're buying that same lock for your house at Lowe's, and you know that the keys don't repeat for 33 million sets of locks, you feel safe? Yeah, I feel pretty safe with that. But when we're encrypting our data, is that enough? Not when we have computers that can check, 10 billion keys per second. It's just crazy how quickly they can break them. Okay, there's 40. Okay, there's 56-bit. So when you hear some people complain, oh, it's only what was the guy complaining about? 256-bit encryption. Okay, he was saying that wasn't enough. But look at 56-bit. Okay? That's how many key choices are with just 56 possibilities. That's a lot. I mean, 56, bit is that many possibilities. Here's 128-bit encryption. Is that a lot of keys? That's a lot of possibilities. Okay? There's 256-bit, and that's considered very poor encryption nowadays. But look at how many numbers that is. That's an awful lot of darn possibilities. And if you're going to be the one trying those pile of keys, no, that's too many keys. But the whole point of this is when you see that, people said, oh, it's only 1024 encryption. That's 4 times greater than that. It's actually exponential. So that's a lot. I don't think I put a number bigger than that because I couldn't get it to fit on the screen. Oh, yeah, I did. Yeah, I did. There it is. There's 1024. But, I mean, just look. There's 256. Look at how big 1024 becomes. That's a lot of darn numbers. Okay? And 1024 encryption is what we had for a long time. People thought it wasn't enough. Okay? That's an awful lot of combinations of keys. It means you're going to have to try every one of those to do whatever you're doing. Even if you can break millions of passwords per second, that's still going to last you a while. I don't know what number that is, but millions is like somewhere over here by that green line. That's still on like the first row. So. Yeah, that'd be nice. Yeah, just like the first 2 rows. Yeah, I think the first little short row and the full row would be good. All right, so y'all understand? So 1024-bit encryption is still really darn good. But given enough time and enough computer power, will it break this? Yeah. It just might take a lot of time. Might take some distributed processing to do it. All right. Oh, there's 2048. I couldn't remember how many. See, there it goes from that to that. So there's 2048. Like you can get a PGP key that's 2048-bit, and that's what they give you. It's free.
A what?
PGP key. Okay. Yeah. All right. That's the end of number 2. Okay. Let's stop this. I couldn't remember how far I went up on that one.